Okay, and on to question 4. The following diagram gives a right angled triangle ABC with AC is 10 centimetres, AB is 6 centimetres and BC is 8 centimetres. They've labelled those on there for us. The points D and F lie on AC. BD is perpendicular to AC. BEF is the arc of a circle centred at A, and the region R is bounded by BD, DF, and arc BEF. All of that's labelled on the diagram for me, so I don't need to add anything. Part A, I'm told to find BAC, that's this angle here, and I note that in my larger triangle, I have all 3 side lengths. I can just redraw that to make it a bit clearer for myself if I need to do that. So I have A, B, C, AC is 10, BC is 8, and AB is 6. And so to find BAC, I'm going to use my cosine rule. So cosine BAC, that's this angle here, is equal to 6 squared plus 10 squared minus 8 squared all over 2 times 6 times 10. That's given in your formula book. I can type that into my GDC using my fraction button. So I have 6 squared plus 10 squared minus 8 squared, and that's all over 2 times 60, which is 120. So I have cosine BAC is equal to 3/5, and so BAC is equal to arc cosine 3/5, which is shift cosine, and then my answer, which is 0.927. I'm definitely happier to be working in radians here because I can see that I'm going to be doing something with the arc of my circle, and it's much easier to find areas and circumferences and so on using my formulae that work in radians. And indeed then I am asked to find the area of R. So for part B, the area of R is going to be equal to the area of that sector, ABF, subtract the area of the triangle, ABD. So the area of my sector is nice and easy. I have a half times R squared times theta. But the area of my triangle is a little trickier. It's a right angled triangle, so probably my easiest is just to go a half times my base, AD, times my height, BD, but I don't actually know what they are yet. So I'm going to redraw my right angled triangle, ABD. I know my hypotenuse is 6, and I have a right angled triangle. And so if I take sine A, I get opposite BD over hypotenuse 6. So BD is 6 sine A. And equally cosine A is AD, the adjacent, over 6. So AD is 6 cosine A. So I can use those now. So I have a half times 6 squared times 0.927. I'm not going to simplify that yet because I want to use the answer button on my calculator. Minus a half times 6 sine 0.927 times 6 cosine 0.927. And with that done, I can now type it all into my calculator. So I have 0.5 times 6 squared times my answer, and I'm subtracting 0.5 times 6 sine answer times 6 cosine answer, and I get my answer of 8.051313924, which to 3SF is 8.05 centimetres squared. Looking at my mark scheme for part A, I'm getting a mark for some correct working, for example, substituting into my cosine rule, and then a mark for my correct final answer. For part B, there are a number of different approaches one can use, but the easiest way to do this is my way. Work out your area of your sector, you get a mark for that. Then work out an expression for either AD or for BD. That's what I did as well. Area of your triangle, and then one area, subtract the other, rounding to 3SF at the end. And another 7 marks sorted.